What if I told you that time, this thing that rules our lives, ages our bodies, and shapes our memories, might not actually exist? Or that time may have started, like a spark, and that before that spark, there was no before? Today, we're diving deep into one of the biggest scientific and philosophical mysteries of all time. Where did time come from? Did time exist before the Big Bang? Is time fundamental or an illusion? This is not science fiction. This is real modern physics, from Einstein to quantum mechanics to the cutting edge of cosmology. So buckle up, because by the end of this video, your understanding of reality will never be the same. Life isn't just yours, it's everywhere, it's everything, and we're here to explore it all. Be curious and stay curious. Before we ask when time began, we need to ask what time is. Sounds simple, right? But here's the twist. Physics does not have one single definition of time. In everyday life, time is the ticking of a clock. In Newton's physics, time is absolute, a universal background. In Einstein's relativity, time stretches, bends, slows down. In quantum mechanics, time isn't even a real thing. It's just a parameter. And in some modern theories, time doesn't fundamentally exist at all. Time is slippery. It's fundamental, yet possibly emergent, continuous, yet maybe discrete, reliable, yet deeply mysterious. And this is exactly why the origin of time is such a profound scientific puzzle. Most of us learned in school. The universe began 13.8 billion years ago in the Big Bang. In the simplest version of the Big Bang model, space begins, time begins, energy, matter, and forces appear. According to Einstein's equations, when you rewind cosmic expansion, everything collapses down to a point of infinite density, a singularity, and at that singularity, time hits zero. Einstein's conclusion, time began at the Big Bang. There is no before. Time didn't exist. Stephen Hawking famously said that asking what happened before the Big Bang is like asking, what's north of the North Pole? But modern physics has a problem with this, because singularities don't actually make sense. They're not physical. They're the universe telling us our equations are incomplete, and that means the Big Bang wasn't necessarily the beginning. Enter quantum mechanics, the world of particles, probabilities, and uncertainty. In the quantum world, energy is quantized. Space might be quantized, but time is weirdly treated as a continuous external parameter. This creates a deep contradiction. Because relativity says time is flexible and dynamic, quantum mechanics says time is fixed. So, when we reach the earliest possible moment, the Planck time, our laws of physics simply break. And that forces us to explore new theories. Theories where time might not exist as we know it, where time might emerge from something deeper. One of the most powerful ideas comes from loop quantum gravity. This theory says space-time itself is made of tiny loops, like atoms of space. And when you apply this to cosmology, an incredible thing happens. The Big Bang singularity disappears. Instead, we get a big bounce. In this model, a previous universe contracted. It reached a tiny but finite size. Quantum gravity caused a repulsive force. The universe bounced. Our universe began expanding. This means time existed before the Big Bang. The Big Bang wasn't the beginning. It was a transition, just like a ball hitting the ground and bouncing back. Mind-blowing, right? Another idea comes from quantum field theory and cosmic inflation. In this view, the universe might have emerged from a timeless quantum vacuum, not empty space, but a seething ocean of energy and fluctuations. Here's the twist. This vacuum doesn't have time the way we think of it. Time begins only when the vacuum transitions into an expanding universe. So before the Big Bang, there was no meaningful. Before, there was a state, but not time. It's like asking, what was water doing before it melted? It wasn't water yet, it was ice. Now let's talk about one of the most elegant ideas ever proposed. Stephen Hawking and James Hartle's no-boundary model. In this model, time behaves like space near the beginning. The universe is finite, but has no edge. There is no singularity. There is no before, but not because time didn't exist. Because the concept of before has no meaning. Think of Earth. There's a North Pole, but there is no north of the North Pole. Likewise, the universe has a beginning, but no boundary where physics breaks. Why do we remember the past, not the future? Why do eggs break but never unbreak? Why do we grow older, never younger? This is the arrow of time, and is tied to one thing: entropy, the measure of disorder. The second law of thermodynamics says entropy always increases. So time is simply the direction in which entropy grows. But this leads to a huge mystery. Why did the universe start in an extremely low entropy state? If the universe had been born in chaos, we wouldn't have an arrow of time at all. Time might not flow. Events might not be ordered. So understanding the beginning of time means understanding why the universe began in such a strange, orderly state. Here's where things get wild. Some physicists and philosophers believe that time doesn't exist. The flow of time is an illusion. Past, present, and future all exist simultaneously. This idea is called the block universe. Imagine a DVD. All scenes in the movie exist at once, but you experience them one moment at a time. In the block universe, your birth, your present moment, and your death all coexist. Time doesn't flow. You simply move along the 4D structure of space-time. It feels like time flows, but maybe it doesn't. Another family of theories suggests the universe goes through infinite cycles: expansion, contraction, bounce, repeat. Examples include loop quantum gravity cycles, the ekperiodic universe brane collisions, Roger Penrose's conformal cyclic cosmology. If these are correct, time stretches back forever. There was no beginning, only cycles. So, did time exist before the Big Bang? Let's summarize what physics says. According to Einstein, no, time began at the Big Bang. According to quantum gravity, yes, there was a previous universe. According to Hawking, the question is meaningless. According to inflation models, possibly. The universe may be eternal. According to emergent time ideas, time isn't fundamental, so before the Big Bang doesn't apply. According to cyclic models, time may be infinite, the true answer. Physics hasn't settled the question yet, but we're closer than ever. To finally understand the origin of time, we need a full quantum theory of gravity, better observations of the early universe, deeper understanding of entropy, and maybe a whole new framework of physics entirely. But one thing is certain: we are living in an era where questions once left to ancient philosophers are now being tackled by modern science, and the mystery of time, its origin, its nature, its fate, remains one of the greatest frontiers in human knowledge. If you enjoyed this deep dive into the origin of time, hit like, subscribe, comment. Tell me down below, do you think time had a beginning, or is time infinite? Your thoughts might spark the next big idea. Thanks for watching. Be curious, stay curious.